Today I will be adding salt into water and observing what happens. First, let's get through some background information about water before we do. Water is a polar molecule because it has a bent shape as the oxygen has a slightly negative charge and hydrogen has a slightly positive charge, which makes it asymmetrical. Also, the electronegativity of water is 1.4, which also proves that water is a polar covalent. The intermolecular force that acts on it is hydrogen bonding because there is a hydrogen-oxygen bond. Sodium chloride is an ionic compound as it has a lattice structure. It has both negative and positive charges, and also has a low volatility. Okay, now let's mix salt into water. At first, the water appears to be cloudy, and there is some salt at the bottom of the glass. As I am stirring, the cloudiness and the appearance of salt is becoming less visible. Sodium chloride can dissolve into water because a partially positively charged hydrogen attracts to the partially negatively charged chlorine, and the negatively charged oxygen attracts to the partially positive charged sodium. And so the polar water molecules pull the ions out of the crystal. This is an example of a dipole-dipole force because there is a partially positive charged side and a partially negative side in both water and sodium chloride. Because of this, sodium chloride separates into sodium ions and chlorine ions in water. Gradually, the salt completely dissociates in the water. Since like dissolves like, we can conclude that sodium chloride is polar because it completely dissociates into water.